Hey everyone, this is Jaime and I'm going to be showing you my latest project at school. We had to make a search engine. Basically the task was you're given a few downloadable websites, create a database, and access it with given queries. So you have to parse the queries, use Boolean operations, and take intersections of unions of different sets. So I will go ahead and open the Java files in Eclipse. Let's make sure we're on the right workspace. Here we go. Now, this is a pretty cool project. I particularly enjoyed it. Let's see, CS1487, and here we go. So here are all the files. Quite a lot, not too many. But basically, we have three components to break it down. We have the web crawler. We also have the web query engine, and we have, what was the last one? Let's see, our index. So the way everything connects is that the web crawler will parse a given page and return all the links that it contains and creates or starts to store information into an index. And this index contains a mapping between pages and the URLs it contains, and also a reverse mapping. Due to time constraints, this was a bit, I would have to say it's quite excessive. It's not too memory efficient, but it gets the job done. It's fairly compact, not too bad. Now, I'm going to go ahead and switch over and go to the actual index.html file that I have. If I go to my Finder, documents, let's see, we have search engine. So here we have all the compiled classes, the database, some styling, and here are the websites. Not too large, I would say about 10,000, about 13,000 elements. So if I run this, you will see my little homepage of TS Oogle, kind of a play on Google, Turing Scholar Oogle. Turing Scholar is the program here at UT for Honors for Computer Science. Now, the initial search, let's just have a test. The initial search will take a little while. It has to load the database in, so, oh, guess not. It looks like it's running pretty nicely. In 0.1 seconds, it can actually go faster, so if I continue to do this as it warms up, you'll see we'll get around 2 milliseconds. So what this does is it compiles all of the pages that contain an instance of test. Now, I can provide Boolean expressions in here. I can, right here you see 291 results, and this time for the query test. And as a Boolean, as a syntax tree of like Boolean operations, it's represented as test, just a single node. So as you can see, we have this page right here, open a new tab. And if we look at test, we'll see that there's a bunch of different instances. Unfortunately, the control find shows all instances of the single substring test, not the actual word. My program actually searches for the entire string test. So right here, contest, this wouldn't be looked up. Going back now, you can see that this is listed on basically on occurrences. And we have the file name, the location, and a bit of information about the page. I think it's I like the styles personally. Also, another interesting feature that I really invested quite a bit of time in was the implicit ands and being able to create a system where you can parse queries pretty efficiently and also make the structure that you want it to have. So if I type in test chocolate, I'm going to want this to look for pages that have both test and chocolate. If I wanted to have test chocolate as a single phrase, I could do this. So if I try this out, none of them have test chocolate. It's kind of an odd phrase to have. But if I do test chocolate, it will be represented as test and chocolate. So right here, you see the phrase is just test chocolate, a single node. But for this one, test and chocolate, you have, it's parenthesized for you, you have test and chocolate. So the and is the parent and the two children on the test and chocolate. Every leaf will be a word. So here are the next pages, just to show that it works, let's go to test and chocolate. Now there's chocolate, but I haven't seen test by itself. Let's see, there we go. I found one back there. Okay, so I'm gonna go back, and yeah, this can go pretty in depth. You can also have pretty broken expressions. Let's just say or at. So I have 4,048 results in about 69 milliseconds. And you can see here that it combines the test and chocolate based on the precedence, and it says or at. So this is actually really nice. I enjoyed making this. What it basically does is it turns the infix notation into postfix notation and adds implicit ands dynamically. And it simply parses it into an expression tree where you can use negations. Oh, that's another thing. So let me go ahead and show that real quick. If I parenthesize this and put a not, it actually will return test and the De Morgan. It uses De Morgan, so you can see that we initially had test, and this would be and, not chocolate or at. So the not is distributed across the board, and have not chocolate and not at. And so none of these pages should have chocolate or at. And let's go over there. Chocolate, nope. At, nope. I'm surprised it doesn't have at. Anyway, that's it. I really enjoyed this project. It was a great final project. I hope you enjoyed the video as well, and see you next time.